Okay, so we've got a question here with lots of information and it talks about probability. So we recognise that probability quite often starts as a fraction and then you might turn it into a decimal or a percentage to make some workings out easier when needs be. They're telling us it's about 100 customers been put into this, so the number of times go to a shop. So 4 people went no times, 12 people went once and so forth. The question says, what is the probability that customer went to the shop 5 or more times? So 5 or more times is all of these. So basically we've got 13 plus 11 plus 5, so that's 29. And it says, what is the probability? So it's going to be 29 out of 100. So the probability here, 29 over 100. It doesn't cancel down, 29 is a prime number and so forth, and 100 isn't in the 29 times table. The question then asks us to work through with last month the shop had a total of 1,500 customers, work out an estimate of the number of customers who went to the shop exactly 2 times. Right, okay. So from this survey we've got what's called estimated probabilities. So it was done for quite a few people, 100, and for 2 people we estimated that for 2 times 13 people went 2 times. So the probability of 2 times is equal to 13 over 100. So 13% of the time 2 people went. So basically the question's saying we're going to do 13 hundredths of 1,500. And when we work that through, divide that by 100, then we get 13 15s, 10 15s is 150, so 195. So we end up with 195 customers who went that time. And that's basically because we estimated from the data given to us that 13 out of 100 times, so 13%, 2 people excuse me, 2 people went to the shop twice. People went to the shop twice, 13 of them. Okay, so then it gives us a statement that the owner of a different shop is carrying out a survey. He records the age of the first 10 customers in his shop after 9 AM one morning. It says that this may not be a suitable sample, so it gives some reasons why. So basically we've got to think about bias, and we've got to think about sample size, and we've got to think about sample technique. So those are the kind of key things we think about when we're sampling. So does this reduce bias? It records the age of the first 10 customers in his shop after 9 AM one morning. Right. He's certainly biasing it because he's only doing it for one morning, and the shop opens at a variety of mornings. The sample size is very small, and the technique is he's just asking the first 10 customers, so it's not allowing any kind of random selection to make things fair or fairer. So it's basically breaking all those 3. But we just have to write down what we want to say. So we could say sample size not large enough, and we could say bias being created as only testing one. Oh, it's not testing, really, it's sampling, isn't it? So only sampling on one morning. Should be doing more mornings. So that's really what you need to be thinking about when you've got to criticise a sampling technique, is does it create bias, is the sample size large enough, and is the sample technique good enough. This is convenient sampling, just the first 10. Be better off doing systematic or random sampling, random in particular, because it gives all the customers an equal chance of being chosen and so forth. So that's a bit of information about probability mixed in with some sampling.